Today we're going to talk about teaching Planck's law as Planck's constant times c, the hc version, over lambda times the Boltzmann constant times t as an inverse interactive, so wavelength instead of frequency as it's told today. Now, Planck's law as taught today uses the formula here at the left, okay? And that is, it has an equation for the intensity, which is calculated by this comparison of the frequency versus Boltzmann constant times temperature. However, the interesting thing is, if you look over here at the graphic, what you find in the textbook, it's not using frequency, it's using wavelengths. So why is that? And how is a student supposed to understand that? Well, to understand that, of course, you have to do the conversion from de Broglie, and Planck's law, which is that Planck's law times the frequency really is frequency times lambda equals the speed of light. So as a result, the number can become hc over wavelength. Now this does some interesting things because now you have wavelength and this as inverse and interactive. It becomes like xy equals a constant. So as one gets bigger, the other one gets smaller. As the other one gets smaller, the other one gets bigger. They are ultimately interactive. Okay, and now we have an inverse relationship scaled to this hc. Okay, we've done nothing but replace this. But now, as we've been teaching Planck's constant, but in reality, the real constant is the coupled constant hc. And we shouldn't be teaching just the h. It is only used in this equation, and then everybody else we have to end up using this hc. So now when they look at this, they can compare it to Rayleigh-Jeans, which is the basic closed container ideal gas law. And that is the line here marked with the red point going to infinity. That's the inverse relationship. As one goes down, the other one goes up. As the other one goes up, the other one goes down. And at the left, you can see this is hyperbola. And the students can understand those two multiply times each other, and that is how all inverse relationships work. So, as I said, this relates to the closed container ideal gas law. Now, I take that a little differently. I use the formula V volume divided by N, the number of molecules. So now the scale of this equation is the same as the scale of the interaction. In fact, we can now say where the closed container ideal gas law things. When the pressure times the volume is less than gravity, the interaction doesn't happen. Molecules are too far apart to bump into each other enough for thermodynamics to take effect. Now, the interesting thing is there's another boundary, and that is when the molecules get too close together, they stop being thermodynamic gas state, and they become an actual chemical reaction. The electron of one molecule actually goes into the other. Okay? And this is how you get a better understanding of the form here, the HemiChem version of the closed container ideal gas. B times V over N equals Boltzmann's constant, K over B, times temperature, T. But that only applies within these boundaries. Now, this is interesting. That explains the line at the left, but Planck's equation also has some other elements to it. In fact, there's really a great challenge because if you take probability theory and old quantum and new quantum, Even the blue line continues to infinity, but you can see that is the hashed blue line. But you can see that the blue line actually goes to 0. Now that's what I was saying on the last slide, that when there's enough pressure, the maximum penetration isn't a gas state, it's actually the two molecules becoming a chemical reaction. They actually bump into each other. The electron invades the other one. In fact, Einstein, in his heuristic paper, described this failure in blue. He said, these principles fail us completely at the small wavelengths. Now, so instead, what I want to do is to teach Planck's transition as Rayleigh genes, which is the inverse relationship, the red line, and the Wien's law, okay, as the transition from effectively the Stefan Boltzmann equation, and Planck's law is the translation. And what most of the students don't understand is that Planck's law only applies in a very, very small space. It's only effective for maybe 1%. 99% of all chemical reactions are in the regular red line to the right. And all this happens, that inward pressure is because of the Bohr radius. And I've already covered this in other presentations. Thank you.